Hi everyone, and welcome to our video on graphing a limacon. We've graphed two already, so they can take a little bit of time. They do become quicker the more you're used to them. Okay, so I'm going probably a little slow to try to hopefully make sure you absorb it. But we've had two different cases. One thing to point out in these problems is notice, so sine, our first one had a sine in it, and like the emphasis I would say is along the y-axis, so it's long on the y. So remember, sine and y are connected. Cosine over here, I would say the emphasis is on the x-axis. It's like stretched out on the x. So again, cosine and x have a connection. So this number 3, I see a cosine, so I would be thinking, well, it's probably something involving the x-axis. All right, now on this scenario of problems, I have been doing a full graph each time. Let's do it again. So I'm going to set up a blank polar axis where I just have my major axes angles labeled. There we are. And then I like to see a converted equation where really just the y is r and the x is theta. Now that 3 is telling me I should go up 3, and I have a new axis of symmetry. And then the 2 is the amplitude, so I should go up 2 and down 2. So here's 5, there's 3, and 1. And then it's a positive cosine graph, so from here it should be something like that. Okay, and then from that, I can graph our angle, so 2 pi, where the peak is pi, where it crosses the x-axis, or not x-axis, the new dashed axis is pi halves, and one more, this is 3 pi halves. Okay, and even here, I would still make a table where we're saying, oh, all of the angles that would have been x values are really theta in our polar graph, and all of the y values are really r in our polar graph. Okay, so we would have, starting at a radius of 5, angle 0, and then radius of 3, angle pi halves, radius of 1, angle pi, radius of 3 pi halves, oops, sorry, that's the wrong order. Radius of 3, and then the angle is 3 pi halves. And then the radius of 5 and 2 pi. Okay, so all the angles on the right, radii on the left. All right, one thing about this, so what's really good, I've been breaking them down pretty slowly on these, and this one I got lots of colors involved. But the first one as well is similar to this. Notice it never crosses this x-axis. So that means all of our radii are positive. So that means when we are starting to plot our points, whatever quadrant our angle is in is where the points should be. Okay, so all positive r in this scenario. All right, and then now we'll just plot our points the best we can and connect them. So plot point number 1, 5 and 0. Okay, so it's saying go to angle 0 and then count 5. 1, 2, 3, 4, 5. And that's where that point should be. Then our second point, point 2 here, is radius 3 and angle pi half. So it's saying start at pi halves and then go 3 toward it. 1, 2, 3. That should be point 2. And like we said already, all the radii are positive. So that means when I'm in quadrant 1, all of the radii are already positive, positive r. So that means connecting these 2 points should be through quadrant 1 with some type of circular-ish shape. And there we are. And then moving on, step 3, or point number 3. Point number 3 has a radius of 1 and an angle of pi. So it's saying go to your angle pi, go toward it a length of 1. So that is right there. So that's our third point. And still, from 2 to 3, I'm in quadrant 2. And it might even help, I didn't do this on the previous ones, it might help though to squeeze in the quadrant. So that one's a little messy. 1, 2, 3. So between 0 and pi halves is quadrant 1 information, pi halves to pi is quadrant 2, and so forth. Okay, so that means from 2 to 3, I'm in quadrant 2, and all of my radii are positive, positive r. So that means connecting 2 to 3 should be with some circular-ish shape like that. Okay, so something like that. And then now my next point, point 4, is 3 and 3 pi halves. So it's saying go to angle 3 pi halves. Go 1, 2, 3 toward it. And then again, from angle or point 3 to point 4, my angles are all in quadrant 3. We've already said that all of our radii are positive. So connecting point number 3 to point number 4 should also again be some circular-ish arch like that. It doesn't have to be perfect, so mine, it's hard to draw these perfect. And then now the last point, number 5. 5 and 2 pi. Okay, so here's angle 2 pi. 5 is back to the start. And then I would be in quadrant 4, but all of the radius, all the radii are positive. So that means they should all be in quadrant 4, connecting that, something like this. Okay, so what we get out of this is it's a dimple. Okay, so it's hard to tell based on the shape. And all of these we could graph in Desmos. Just type it in exactly the way that you see it. So if you type this in Desmos, that would give you a much prettier graph than what I can currently draw. I mean, mine aren't terrible, but theirs would be, it's a calculator, so it can do things a little bit more accurate than I can. All right, but anyway, so this is the dimple. So that's this last case. So a dimple, so it's, to me, it's kind of like was a circle that kind of got either dropped or punched. I don't know. So this one got, so a dimple, like when certain people smile, they have dimples in their cheeks. So it's kind of like that is what they're saying is the shape. Okay, so you've got the 3 different ones, just dependent on the sizes of A's and B's. And I would, if you want to try just memorization, fine. But I would think trying to get these graphs and tables going can help. I think it's kind of nice too, just graphing the y and x scenario of it to remind yourself how to graph these trig functions for when you might need it again for calculus. Okay, so if you have to take calculus, but if not, maybe just do the tables or try the memorization. So there's different ways to do these. Okay, so that's it. Thanks for watching. If you have any questions, please let me know.